So this is the last section, last couple sections in Chapter 1. We've moved from transforming graphs and dealing with functions and a lot of algebra to 1.3, which was triangles and a little bit of geometry, and now we're moving to 1.4, and we'll be dealing with circles and really lay the foundations for trigonometry second semester. So the flipbook notes for today was combined 1.4.1 and 1.4.2. I'm really only going to do the flipbook notes for 1.4.1 because that talks about the relationship between radians and degrees, and then 1.4.2 is just building the unit circle. So if you turn to your flipbook 1.4.1 at the top, in class we discovered the relationship between radians and degrees. So at the top of your flipbook you can write in the word radians. And that noise in the back is my son trying to go to bed, talking to himself. And you can think of radians as radius, angle, and you can see the word radian in there. And that's essentially what it is. When you're thinking of radians, remember the activity we did with the circular disc, and radians just represent how many radiuses it took to make up that circumference. So, speaking of the disc activity, you all brought in a circular disc today, and we ended up figuring out the circumference of it, and then figuring out how many radiuses it took to make that circumference. So I'm going to kind of draw a sketch of that. Oops. Okay, so we talked today about the circumference of a circle, and we realized that part of the radius, it takes a certain number of radii, or radiuses, to make up the entire circumference. So we can call this R, 1 radian, and all that means is 1 radius length of the circle. And in class, we ended up discovering that it took about, to fill up the circumference, it took about 6 radian lengths to get around. And actually, this was a little bit more than 6. So we can actually change the symbol to a little bit more than 6 radians. A little bit more than. Actually, we should probably say just approximately. Should have got a little bit over 6. When we looked at this further, we saw that C is actually equal to 2 pi radians, because 2 pi is equal to approximately 6.28 radian lengths around. So a lot of you, when you measured with your tape, you got about 6 radians, some a little bit over 6, which was really close to the actual estimate. Now from here, in class we talked about how this relates to degrees. If circumference is your distance all the way around a circle has 360 degrees in it. So we can think of the circumference as being 360 degrees is equal to 6.28 radians, or 2 pi. Now, this isn't as simple as you can get. We devised a simpler form by dividing each side by 2. When you do that, you end up getting 180 equals pi. And this is the important ratio that we will need, or equation we'll need, to translate between radians and degrees. So we can think of 180 as my degrees is equal to pi, which is our radians. And we're going to use this relationship to help us convert between the two. So if we go to the next slide, we'll look at an example, and I'm going to take you back to Thompson's chemistry class. We're going to do a little stoichiometry, a little unit conversion. So we'll start by converting to radians. And when you're thinking about this, think Thompson's class, think stoichiometry. We're we're going to be doing a simplified version of it, but essentially we're trying to convert between units. Okay, so A looks like this. Say I want to go into radians, and I know I'm going 90 degrees around the circle. The question becomes, how many radians is that? Now, I gave you the equation earlier as 180 equals pi, but we can write this as a ratio by saying one of two things. Either pi over 180 or 180 over pi. Now, both of them represent the same thing. It just depends on what unit we're trying to convert to. So here we're trying to convert to radians. And if we're trying to convert to radians, the equation we want to use is number 1, pi over 180. One way of thinking about this, the unit we always want to get to will always go up top. So if we're going to degrees, we'll put degrees up top. If we want to go to radians, we'll use pi. Now, once we end up or actually not cross-multiplying, but just multiplying, you'll notice the degrees cancel out. So we end up getting 90 pi over 180, and this can be reduced even farther. 90 and 180 can be divided by 90 to get 1 over 2 pi, or even a simpler form, the form I want you to put it in, pi over 2. Okay, and that should make sense, because if you think of a circle, halfway around the circle is 180 degrees, and that's pi, and half of 180 is 90, and half of pi is pi over 2. Now, let's do another one. Let's say, instead of giving you 90, a nice angle like that, let me give you negative 36 degrees. Think about which ratio you're going to use. If you're going to radians, radians needs to be on top. Pi over 180. Again, same ratio as before. You'll get degrees cancel, so we get negative 36 pi over 180. Now, I don't want you to grab your calculator. I want you to think what divides into both of these, and a lot of you would say 6, but you can actually go even higher. 36 divides into both of these evenly, so if you do 36, you'll get negative 1, and 180 divided by 36 is 5. So your answer here, don't forget that negative, is negative pi over 5. That negative is going to become important later when we deal with the unit circle. Now let's go the other way. Let's say now I want to move not into radians, but I want to move into degrees. So we'll convert to degrees. And we'll look at two examples here. Here's the first one, negative 7 pi over 6. Again, look at your two ratios. We're trying to go into degrees, so we can put degrees up top. So it'll be 180 over pi. There's your degrees. And you'll see again, the pi's cancel. And before you grab for your calculator, look at the 180 and the 6. 7 can't be divisible by 6, but 180 can. So if we simplify this by 6, we get 1, and 180 divided by 6 is 30. So now you have 30 times negative 7, and 30 times negative 7 is negative 210 degrees. So here, a lot of you are going to want to reach for your calculator. Make sure you are simplifying first. Simplify first, and then grab for your calculator, because I don't want you getting decimal answers. Alright, the last one. This is probably the toughest one. Students kind of freak out when they see this. Convert to degrees again. Convert 2 to degrees. Now students kind of freak out because they don't see the pi, but we're going again to degrees, so you're going to use the same ratio as before, 180 over pi. And the pi's don't cancel, so we end up with 360 over pi. Which you can plug in your calculator. I think you get something like 114.6 degrees. Now, if you think back to the disk activity, this should make sense, because if we draw a circle, let's go ahead and sketch a circle, and we think about 180, 180 is right in the middle. This is 180. And 114 then is probably going to be right about here. Somewhere around there. And if we know it's 2 radian lengths, then if we go back to our circle, we should have about 2 radius lengths. And we look, one's going to be there, the second one's going to be right there, and the third one's probably going to be right about here. Because you know 3.14 is 180. And if we keep going around 4, 5, and 6, sure enough you get to 6.28 at the end. So this should make sense that 114.6 degrees is the same as 2 radians. Okay. Alright, I hope that helps. I know these are kind of lower level questions, but they will provide kind of like they'll be the tools for us to do higher level questions later in the course. Alright, hope you enjoyed it, and study for that team test.